we're going to be talking about polar coordinates. But to get there, we're going to start by representing a point we think with rectangular coordinates. So let's just consider the point 1, 1. And in rectangular coordinates, we could graph that pretty easily. Here's the origin. We move 1 unit in the x direction and 1 unit in the y direction. And that's the point represented by 1, 1. But consider this. There's another way to describe this point. Instead of moving 1 unit in the x direction and 1 unit in the y direction, we could instead consider turning in this direction, and we'll call that direction theta, and moving from the origin out to that point r units. So for this particular problem, if this is 1 and this is 1, we know, looking at that triangle, that theta would equal 45 degrees or pi over 4. So we could describe this point by saying first to turn in the direction pi over 4 or 45 degrees and then travel that length. Well, what is that length? I hope you recognize the triangle as an isosceles right triangle. So if this is 1 and this is 1, r would be square root of 2. So when we describe this using polar coordinates, instead of having an x, y, we will have an r and a theta. So this particular point represented here would become square root of 2 pi over 4. So r theta. So let's practice graphing some points using polar coordinates. Now the grid looks a little bit different because we're using r and theta. Now my grid looks like this. And let's plot a few. Suppose we had the point 4 pi over 6. And I'm going to call that point A, and we'll just label it on our grid. That means we turn in the direction pi over 6. So when we start here at 0, turn in the direction pi over 6, and we're going to go out 4 units. And notice I've already labeled the increments 1, 2, 3, 4. So from here, the way this is labeled, we'll move in the direction pi over 6, out 1, 2, 3, 4 units. So this is our point A. And let me talk a little bit about some vocabulary. In rectangular coordinates, we call this the origin. With polar coordinates, we call it the pole. So the origin is now called the pole. And this positive x-axis, as we'd call it in rectangular coordinates, is now called the polar axis. So we have the pole and the polar axis. Let's graph another point. Let's suppose we have the point B, which is 2, 3 pi over 4. So let's plot that point. So I start here, I turn in the direction 3 pi over 4, and this tells me we're going to go 2 units in that direction. So starting here, that was 1, 2. So here's the point B, right here. Let's graph another one. Let's make C be represented by the point 3 negative pi over 2, because there's nothing that says that the theta must be positive. So we start here and we turn in the direction toward negative pi over 2, which you know is coterminal with 3 pi over 2. So I'm turning in this direction. So if I'm actually sitting on the pole right here, I would be thinking, I'm standing here and I would think, okay, now I'm traveling in this direction 3 units. So from here, 1, 2, 3. And I just consider it as if I'm standing right here and I turn in that direction and travel. Let's do another one. How about the point D, which we'll let be -2 7 pi over 6. Now, notice our R value is negative. That will be a little bit different, but still, we're starting here. We're turning in the direction to 7 pi over 6. So if I'm standing right here at the pole, looking at 7 pi over 6, the terminal side, right, is here, except this says to go backwards. We go in the opposite direction 2 units. So 7 pi over 6 is here. I'm going to go backwards 2 units. 1, 2, and the point D would be right here. Let's do one more like that. Let's make the point E be -6, -3 pi over 4. Might as well make R and theta be negative. So let's start with the angle. So we're here. -3 pi over 4, we're going in the negative direction. We'd be right here. Here's our terminal side. And now it says to go backwards 6 units. So I'm going to not go this direction. I'm going to go in the opposite direction 6 units. 1, 2, 3, 4, 5, 6. So here's my point E right here. Let's do another one. And let's start with the clean grid. This one. We're going to plot these 2 points. Let me come in a little bit closer here. I have a little smaller grid. Not as many lines to look at. So we're going to plot the point 3, 5 pi over 4. So again, I'm starting here. And remember, this is the polar axis here. We're looking at that 0 angle. And we're turning to 5 pi over 4. So I'm looking in this direction. And we're going to travel 3 units from here. I'm just going to have this be 1, 2, 3. So here's the point. Now look at this one. Oh, this one we are going to go to the angle 13 pi over 4. Notice that's bigger than 2 pi, so that is more than 1 full rotation. Let's see, what would that look like if we subtract off 2 pi so we can find the angle coterminal with it. If you subtract 2 pi from 13 pi over 4, let's do that. 13 pi over 4 minus 2 pi, which is 8 pi over 4. We get 5 pi over 4. In fact, has the same terminal side as this one. So we have this same terminal side. We still go out 3 units. And in fact, these 2 ordered pairs represent the exact same point. Very different than rectangular coordinates, because in rectangular coordinates, every point is uniquely defined. And here we've just seen that this particular point has 2 different representations. And in fact, there are more. We could add another 2 pi to this, right? Add 2 pi. Let's see, that's adding 8 pi over 4. And we would have 21 pi over 4. That would be another representation for this point. And there's still more. What if we used a negative R value? Remember, we can use this angle. What's the angle opposite this 5 pi over 4? Opposite would be over here at pi over 4. So we could come over here to pi over 4 and use an R value that's negative. So I'm saying that if I move up just a little bit so we can see a little bit more, we make the theta be pi over 4. So exact opposite from this one. So if I were turning in the pi over 4 direction, I'd be over here. But now we would move backwards 3 units, and we would have a negative 3 pi over 4. And we have another representation for this particular point. In fact, every point can be represented an infinite number of ways, because we certainly could keep adding 2 pi to this angle, multiples of 2 pi, and similarly here, I could add multiples of 2 pi here also. So that brings me to the next problem. Let's suppose we have directions that look like this. We're going to be given a point in just a moment. It will say the directions are plot the given point. And let's move up just a little bit so we have some workspace. Plot the given point, and then find 3 additional polar representations of the point. And we're going to keep theta between negative 2 pi and 2 pi. Without that restriction, there would be an infinite number of possibilities. So let's start with this one. So 5, 3 pi over 2. So let's start by graphing it. We know we're going to turn to 3 pi over 2. So I'm here, I turn until I'm looking in this direction. I'm standing right here at the pole looking in the direction 3 pi over 2. And I travel 5 units. 1, 2, 3, 4, 5. So this is the point that we're talking about. So we want other representations for this particular point. Let's keep our R value positive for a moment. Now remember, any angle that's coterminal with this would give us a representation of this particular point. So I could add multiples of 2 pi. So I could add 2 pi, 4 pi, 6 pi, and so on. But if I add 2 pi to this, I would be beyond 2 pi. But nothing says that I can't subtract 2 pi or subtract 4 pi and subtract 6 pi. Those are also multiples of 2 pi. So if we subtract 2 pi from 3 pi over 2, we can do that right here. 3 pi over 2 minus 2 pi. Let's think of it as 4 pi over 2. We would get negative pi over 2. So another representation of this point would be 5, negative pi over 2. We could continue and subtract another 2 pi, but then we'd be at negative 5 pi over 2, and we would be outside of this interval right here. So we have all the possible representations with our R value being positive that keep theta between negative 2 pi and 2 pi. So that means we need to move to our R value being negative. So remember what that means. Instead of using 3 pi over 2 or negative 2 pi, we're going to use the angle opposite it. So we're going to use this angle, pi over 2. And if we turn in the direction pi over 2, then that means we need to go backwards 5 units. So we would have negative 5 pi over 2 as a representation for that point. And now to find other representations for this point, we can add multiples of 2 pi. Again, add 2 pi, 4 pi, 6 pi, or subtract 2 pi, 4 pi, and 6 pi. But keeping in mind, we're going to stay between negative 2 pi and 2 pi. I don't want to add 2 pi. That would be bigger than 2 pi. So let's subtract 2 pi. So we're at pi over 2, and we subtract 2 pi, and we're at negative 3 pi over 2. So negative 5, negative 3 pi over 2 is another representation for that particular point. Let's practice one more. So here it is. Oh, I need to have a clean piece of paper. Let's get rid of that one. The directions are still the same. Plot this point and then find 3 additional points. And let's keep in mind that we're going to maintain theta between negative 2 pi and 2 pi as we come up with those additional points. So we turn in the direction pi over 3. So from here, I'm looking in this direction, pi over 3. And we are going backwards 4 units. So 1, 2, 3, 4. So here's the point that we're talking about. Let's maintain our R value the same. We'll keep it at -4. And remember, we can come up with any angle that is coterminal with pi over 3, and it would be another representation of this. Again, add 2 pi or 4 pi or 6 pi, or subtract 2 pi or 4 pi or 6 pi. If we add 2 pi, it will be too big. It won't be in this interval, so we'll subtract 2 pi. So I have pi over 3, subtract 2 pi. I'm going to think of 2 pi as 6 pi over 3. And we get -5 pi over 3. So there's my other representation, keeping my R value the same. So -5 pi over 3, -4. I said that backwards. -4, -5 pi over 3. That takes care of all of the angles between 0 and 2 pi if we maintain our R value that's negative. But let's make our R value positive now. Our R value is +4. And notice we can look at the picture right here and see it. Notice this is the angle 4 pi over 3. So we could use 4 pi over 3, 4. Notice it is opposite the pi over 3. And in fact, notice what you can do. We add 1 pi to this angle. If you add 1 pi or subtract 1 pi, you'll get the angle opposite the one that you're talking about. So now we have this representation for this point. We need one more. We'll keep our R value the same. We need an angle coterminal with this, so you can either add or subtract multiples of 2 pi. Adding 2 pi will put it out bigger than 2 pi, so let's subtract 2 pi. So 4 pi over 3 minus 2 pi, and we're at -2 pi over 3. So 4 -2 pi over 3 is another representation of this particular point right here. And I hope you can go practice plotting some points using polar coordinates.